So what we're going to do now is take a look at the frequently made mistakes I've seen thus far for assignment 3B. This is the one where you're implementing the fair semaphore using either monitor objects if you're doing the undergrad version or reentrant lock and condition objects if you're doing the grad version. First and foremost, please make sure to document your code thoroughly. There's lots of solutions that haven't got any comments in them, and then it's very mysterious what people are thinking when they're implementing it, so it makes it harder to provide feedback. Here's something that's left over from the previous assignment. I think this is assignment 2A. Make sure that you have the right parameter type for the list, which is the future list in the Executor Service Manager. But that's just kind of a vestige from previous assignments. Okay, let's get into some issues I saw with the undergrad version. This is the constructor for fair semaphore MO, which stands for monitor object. And this code is missing something important. If the person were to have run the tests, the code would have blown up because there's something that's not being initialized. Let's take a look down here. This is something that's really strange in the acquire method. The acquire method is actually one I implemented for you. There is no to-do tag in that method, but for some reason, this person added some additional locking operations, which are completely unnecessary and confusing. So you don't need to have that kind of stuff in here. Taking a look down here, now let's take a look at a bunch of problems with try to get permit. So there seemed to be some confusion. If you read the specification comments carefully, you'll see that try to get permit does synchronization, but no implementation, and it simply forwards to try to get permit unlocked. So you don't need to have this implementation code in try to get permit. That belongs in try to get permit unlocked. Down here, this code is incorrect also. Number one, you don't need to have the implementation part here. You need to forward to try to get permit unlocked. But more importantly, in this context, the code is actually supposed to synchronize. And this is just checking to see if the lock is held, which is not the same thing as ensuring that synchronization is in place. Down here, yet another problem. This implementation also doesn't have any synchronization. So make sure you synchronize things properly before you forward to try to get permit unlocked. And the grad student and undergrad versions of this code are ever so slightly different because of the differences between reentrant lock and its semantics and synchronized statements, which are fully bracketed. Here's yet another problem. This particular implementation doesn't meet the specification. This is the grad student version, of course. And the grad student version is, if you read the comments carefully, it's not supposed to release the lock if it was unable to acquire the permit. And that's so it can be held until wait for permit gets called. Now let's take a look at some problems with try to get permit unlocked. In this case, the comment is that you're not supposed to use any synchronization in this method. This method is synchronized, so that's incorrect, of course. So try to get permit unlocked is the one that just does the work but doesn't acquire the lock, whereas the try to get permit method acquires the lock and then forwards to try to get permit unlocked. Now we're into the really hard one. This is wait for permit. And so far, I haven't seen anybody whose code is free of bugs. So let's talk about some of this stuff. So a couple things to keep in mind. First of all, whenever you access state in the fair semaphore MO or fair semaphore CO object, you need to make sure that you have the monitor lock held or the intrinsic lock held. If it's the grad student version, then there's going to be a monitor lock that's a reentrant lock. If it's the undergrad version, it'll be the so-called intrinsic lock, which is the one that's involved just by virtue of the fact that every Java object is a monitor object. So whenever you access something like the wait queue or whatever you call this thing, you need to make sure that the monitor lock is held. And this code doesn't do that. So that's a problem. Other problem here is it's calling try to get permit unlocked in the wrong place. You need to call try to get permit unlocked, and only if it's not able to get a permit would you go ahead and add the waiter to the queue. Otherwise, you're done. You can bail out. And then this code here where we're calling wait on the waiter, that is also very incomplete. There needs to be a loop when you do this. There needs to be a condition that's checked when you do this. And I think we've got some other examples that'll talk a bit more about that. Okay, let's take a look at another example of a problem. So once again, this code has a race condition in it, or at least one race condition in it, because the waiter.mReleased field is being accessed without being properly synchronized. So you have to make sure whenever you access the field of the waiter that the lock associated with that waiter is properly held or synchronized or whatever. So that's going to be a problem. Down here, you can see we kind of got this backwards. We're synchronizing on the waiter, but we're first checking to see if the waiter.mReleased is true or not, and that's not synchronized, so it's a race condition. Likewise, when you call try to get permit unlocked, you need to check the return value. If you're able to get a permit at this point, you're off the hook, you're done, you should bail out. But if you're not able to get the permit, then you have to go through the trouble of basically putting the waiter into the wait queue. So this is confusing and incorrect. There's another race condition here because the intrinsic lock isn't held. Calling try to get permit unlocked, you need to make sure that that's properly synchronized. I should also point out here, let's see, there's also a race condition here, since the intrinsic lock isn't held. So you got to make sure you hold the intrinsic lock. The reason that's important is that try to get permit unlocked accesses the state of the fair semaphore by taking a look at its permit count and whether the wait queue is empty or not. And again, you need to make sure you take a look at the return value of try to get permit unlocked to know what to do next. This code is backwards. You need to make sure that you synchronize things in the right order. This is just confused. It's also in the wrong place. And you need to make sure that you always call wait in a loop and make sure to check the proper condition. So there's a condition you need to check and you need to loop while that condition is not true. And then down here, this is handling the code in the catch portion, but there's a race condition here since the intrinsic lock isn't held. And that's going to cause problems. So once again, there's a race condition and this code needs to be cleaned up. So lots of issues with synchronization here. The unit test will catch some of this stuff. Unit tests can only do so much, so you actually have to sit down and think carefully about this. The main thing you should be thinking about with respect to the wait for permit method is where do you have to hold the intrinsic lock to protect the state of the fair semaphore object, and where do you have to hold the lock on the waiter? And the waiter is just the object that you're going to be using in the wait queue to wait in a FIFO order for your turn to get the next semaphore acquisition. And you got to be very thoughtful about that, very, very subtle. And that's why you should read the specific notification pattern article by Tom Cargill to really get a better sense of what's going on. Let's see. So here, you don't just unilaterally add the waiter to the wait list. You should, or the wait queue, you should only do that if try to get permit unlocked returns false. And again, make sure that you call wait in a loop and use the mReleased field in the loop condition. So this is sort of a repetitive set of problems that we've seen over and over again. All right, now let's turn our attention to release. So release is not nearly as tricky as wait for permit, but it is tricky. And so a couple things to note here. You should please refactor your code so that the intrinsic lock, so that the monitor lock isn't held any longer than it's absolutely necessary. You can kind of do this in a clever way so you don't have to hold it throughout the entire scope of the method. This call is the wrong method to call here. Calling wait will block. You don't want to block, you want to notify, so that's the wrong method. And there's no need to have a catch clause here. Coming down here to another example of problems with release. This code has race conditions. There's no synchronization anywhere. As you can see, the count's being incremented. The queue is being checked to see if it's empty. An item's being removed, et cetera, et cetera, et cetera. And all those things are being done without the lock being held properly. And there's also a lot of other stuff missing here too, having to do with doing the notification and so on. Yet another problem with release. This code has race conditions since it's not properly synchronized. Again, and I recommend using poll instead of get first or move first. There's no need to call those two methods. Poll is more concise and has some other nice properties if you use it properly. Here, there's something important missing. You have to do more than just notify the waiter. You have to also set its flag to indicate that it's been released. And of course, down here, this is going to be a race condition because we're incrementing the permit count, except in this case, there's no lock held. And you also have to be very careful not to always increment the permit count. You only want to increment the permit count under some conditions, like there's an item available. Okay, now let's turn our attention over to the concurrent hash map fair semaphore Palantiri manager implementation. And so the first thing here, make sure you initialize the Palantiri map with the right type of map. If you take a look at the comment, it says to use a concurrent hash map. This is using a hash map. Obviously, that's not the same thing. And if you use a hash map, it defeats the whole purpose of using the concurrent hash map, which is to avoid having to do any explicit synchronization. Speaking of explicit synchronization or non-explicit synchronization, here's the acquire method. I recommend not using Java streams here, but instead use nested for each loops and also use the 3-parameter version of concurrent hash map replace. So that's being used here, but it's being used in other ways that it will not work effectively with multi-threading. Here's another implementation of acquire that has some problems. First, you need to start with a forever loop. And the reason for that is that because there's no locking over the entire concurrent hash map, some interesting things can happen. So you may need to loop more than once through the map. When you loop through the map, please use key set instead of entry set. There's no need to use the key set. And here we go. Don't use Palantiri map.get. That defeats the whole purpose of trying to use the 3-parameter version of replace. And speaking of the 3-parameter version of replace, you need to use the 3-parameter version of replace rather than the 2-parameter version of replace. And that's because we're using that super cool atomic check then act semantic for the 3-parameter version of replace, which allows us to basically return true and atomically set the available value appropriately in the case where you want to be able to do that atomically. And if you do everything properly, there's no need to have a replace call at all here. That will have been done using the 3-parameter version of replace. And then last, but certainly not least, make sure that you always check to see if the Palantir is null before you do anything else. So start out by setting Palantir to null, or checking to see if Palantir is null. And if it is null, bail out right away because there's no point in going any further. If it's not null, then you can continue on and do the other sanity checks with replace and so on. Okay, so that is the walkthrough of the frequently made mistakes for assignment 3B to this point. There'll, of course, be a few more days to get things in good shape, but please make sure that you take a careful look at this and apply the fixes to your code. Even if you've already submitted your code, please go back and fix it because you're going to, I'll just have to give you the same comments again if you don't make the changes.